and start running through the agenda. So thanks for coming. This is the, I think, fourth meeting we've had in this pattern of one early US time and one late US time, to try and accommodate people in different time zones. So we're continuing with that for a bit, though we might kind of reach out again and see how things work best, what times are best. I'm going to kick off today with the sort of show and tell section we do. What I wanted to spend some time on was looking at new features that are coming to SingularityCE 3.9, which should be released sometime by the middle of next month. We're expecting to put out a release candidate in the next week or two, and I encourage people to test it and give feedback before the stable release. So if I jump over to the Singularity changelog, there's quite a lot of stuff in this 3.9. We have various things which change some defaults or some behaviors. Some are really fixing sort of deficiencies, but they're marked up here as change behaviors because they do change the functionality of Singularity a little. The main one there, which people have asked for and hasn't worked properly since the 2.x days, was inheriting labels from Docker and OCI images. So just want to point this one out because this fixes a regression from Singularity 2.x. So we inherit now labels from Docker or OCI containers we build from, but you will need to use force if you want to override a label that exists in a Docker or OCI container. And that is a behavior change, because if you've written definition files which set labels and you've only used them in Singularity 3 and above, you might hit this if the same label was set in your Docker base image. So that's one to particularly point out on the changelog. We've have various things affecting how the file section in a definition file is handled to make it more consistent and really fix some issues with pattern matching and things there. Some changes to some flags, and then something I'll show in a second, changes to the way we find external binaries that Singularity calls, a new experimental usage of the Nvidia container CLI to set up GPUs rather than using our own code. We can now call on Nvidia's official tooling to do that. We also have modified our example log plugin so that it's a bit more useful. Have some more checking on things before you do a build. Enabled certain flags under build that were previously not possible there. And we support cgroups v2 systems now with the apply cgroups flag. So for people who've updated to distributions which have switched over to cgroups v2, which has a different kind of layout of the control groups hierarchies. Singularity before 3.9 can't set up cgroups in that format, but from 3.9 onwards, we can apply a cgroups configuration to that kind of structure. But what I want to do here is drop into a shell a minute and show some of the more notable things in that list. So let's first talk about the finding of external binaries on that Singularity calls. So in order to create a container or use a container in certain situations, Singularity is going to call out to the MUX-SquashFS and unsquashfs tools. It's going to use crypt setup if you're trying to work with encrypted containers, and various other things. What we've seen over the past year or so is that there are more and more installations which are using things like custom package managers, which sit on top of a standard distribution, things like Nix and GUIX, and also people who are compiling, say, a new version of SquashFS tools for deployment on their cluster, to work around an issue in a distro version, and so on. Now, in the past, when you built Singularity, it would look for some things and record where they were at build time. Some things were sort of specified in the Singularity conf where they should be looked for, and most things were just searched for on path. And this was a bit inconsistent as well. So we had situations where some of the handling of SquashFS, the MUX-SquashFS, sometimes we'd look at a configuration value and sometimes we'd try and find it on the path. Now, what we've tried to do with 3.9 to help people who have these systems where not all of the external binaries are in the usual standard distribution places is really look and change the code so it's all managed in one place and it's consistent. When you go and configure Singularity to build, it's going to find at build time a number of the most important things that we call out to, which will really break functionality badly for a lot of workflows if you can't find them. And it's going to find these during build time. And then if we go and look in the Singularity conf, what's going to happen is that it's going to set at install time the paths that it found these important external tools. And it's at runtime going to use these paths from the Singularity conf. So if you're an administrator and you're using some particular path and you know it needs to be used by Singularity, but your users are installing Conda, setting various paths and so on and getting a bit of a mess, Singularity will now consistently look at these places for the core binaries it needs to call. And the rule is that it will look at the path that's set in here. If you come in and you change the path after installation, then it'll go and look at the new path. If you remove the path which is specified in these files, if you leave an empty string, then it's going to search on the path environment variable, and it's going to include kind of force checking standard user local bin and sbin, user sbin and bin, and sbin and bin. So we have the best chance of finding things. So we're hoping that this will make it easier for people who have systems where they're not relying on everything just being installed by the distribution. Any questions about that a little bit? Okay, so the next thing I have
a question for you, Dave.
Yeah.
I said the default was to search with $path. Is that those all run unprivileged?
What, those binaries?
Yeah. Or will it search only a like if it's in a set UID portion, it won't use the users?
Okay, so there are some notes there. There are like Nvidia container CLI, which is found will in certain circumstances be run privileged. And there's a note actually on the config there that the code checks that it must be owned by root in that situation. So it is tackled based on how the binary will be called. Okay. Okay, so the next thing to look at here is the GPU work we've been doing. So for a long time, Singularity has supported using Nvidia GPUs, and more recently AMD GPUs that use ROCm instead of CUDA. And the way we kind of enable a GPU in a container is by making sure device files are present in the container and having a list of libraries and binaries that we bind into the container when you run it with the NV flag. So this works pretty well. But there are some limitations. If I'm on a machine like this one, which has 4 GPUs in it, then I run a container with Singularity run --nv, and Singularity makes all of the GPUs available in the container. The only way I have of restricting the GPUs which are used by a particular container run is to set the environment variable CUDA visible devices, right? And I can say maybe 0,1. And what this does is it instructs any CUDA program to use only GPUs 0 and 1. That kind of works for most CUDA programs, but it's not a hard restriction. Whenever I run a container with NV and I drop into it, I will always see the same set. Even if I set that environment variable outside or inside the container, I'll always see all of the GPUs. They're all present. And a program can just kind of ignore the CUDA visible devices setting or override it in certain circumstances. So it's not a good sort of restriction when you have these big machines with multiple GPUs and you want to make sure people as containers are running on different GPUs. So the Nvidia tooling to sort of handle GPU setup for Docker containers can be called not just from Docker, but in other container runtimes. And that's what we've started to do with a flag, an experimental flag for Singularity 3.9, which is NVC CLI for the Nvidia container CLI. So if we run the container with this, we'll see that it's saying it's setting a writable tempfs flag, which is something that's required by this Nvidia tooling. It has to be able to write some things into the container file system. But inside now, rather than Singularity itself doing the binding of all the libraries and things like that, we've asked the Nvidia official tool to do it for us in the same manner it would if you've installed the Nvidia Docker runtime and you're using that. By default, we have it working in the same kind of way as Singularity does without this NVC CLI. So if I look at the output of mount, the list of things that are mounted by the tooling, the libraries, and if we look at NVIDIA SMI, we see all the devices. This is basically just kind of the same as what we get with Singularity, but using the official tooling. So far here, the chief advantage we have is that if Nvidia change their drivers and incorporate new libraries or things like that, if your system has their official Nvidia container CLI on it, if you update that, then you will be able to pick up those CUDA library changes and things without Singularity having to be modified, or the list of libraries that Singularity has kind of hard-coded needing to be changed. But where things get more interesting is where we start to use some of the functionality of Nvidia container CLI that is commonly used with the Docker runtime. So it supports a number of environment variables. Now, to start making use of these, to limit GPUs that are available in the container, I'm going to add the contain flag to my Singularity run. Now, if I do this without the NVC CLI, Singularity will still bind in all of the devices, all the GPU devices into the container, because I'm saying I want NV, so it's assuming I want GPUs in the container, even though this contain flag otherwise sets up a minimal device tree. Okay, so I add contain, and I'm using the NVC CLI. Let's see what happens. Okay, now it's telling me that, oh, I'm not going to get any GPUs. Let's verify that. Okay, so we have no GPUs in the container at all. What do we need to do to get our GPUs back? Well, let's run NVIDIA SMI. We have 4 GPUs, 0, 1, 2, and 3. Let's imagine that I want to use 0 and 2. What I can do is set the environment variable NVIDIA visible devices, which is different from CUDA visible devices. Say I want 0 and 2 and start my container. Now, I'm getting 2 GPUs which aren't consecutive. So I'm getting the one with PCI bus ID 1B and 1D are the ones I expect to see in my container. And sure enough, now I do have these 2 GPUs, and I've got 1B and 1D. So they're numbered as 0 and 1 inside the container, but they're actually the 0 and 2 from the host. So now we've got a really kind of hard way to control which GPUs are available in a container, which is quite a common thing which people ask about when they're running containers on these big nodes with big sort of A100 GPUs and things like that, and multiple of these GPUs, which a lot of jobs they just really don't consume completely, but you want to run different containers on there at the same time, and you want to make sure for certain that they won't tread on each other's feet on the GPUs they're using. So that's kind of the chief benefit of using this approach where we're going out to the Nvidia tooling. I will mention that there's a situation you can't use this. Okay, I can't currently use the NVC CLI option if I enable fake root and my Singularity install is set UID. This is kind of an artifact of how Singularity's fake root functionality is written. So it doesn't call out to external binaries to set up sub-UIDs and sub-GID maps. It does it itself. And it does certain setup privileged with its own set UID capabilities. And in that circumstance, the order of operations doesn't fit with NVIDIA Container CLI yet. So that's something that will need a bit of work. If your Singularity install is not set UID and you use fake root, then things will actually work because Singularity uses a different setup process. The other issue that arises with this at the moment is that certain distributions, like the latest Debian, aren't perfectly supported by the NVIDIA Container CLI. They have some problems with library location and library caches. And it's not entirely clear yet how that's going to be solved by the NVIDIA Container CLI. So these kind of things are why we're exposing this in 3.9 as an additional flag you have to add it as an experimental feature, okay, so that you can try it out. and the default is still the old way of doing things, which doesn't have those two restrictions at present. Any questions on this one? Okay. The last thing I want to show out of the kind of, I'm just cherry picking out of the changelog a bit, is that we've added a flag called mount. So what the idea of mount is to offer an alternative to our bind flag for two reasons. So the first reason is that the bind flag uses a colon to separate a source path from a destination path in the container. So if I, for whatever reason, have a source directory which itself has a colon in it, I have a bit of a problem specifying that mount. Now, I know that this is an issue which was tackled a little bit differently in the HPCNG Singularity repository, where some quoting was used. We've done things a little bit differently because we saw the opportunity also to improve the compatibility with the Docker command line a little bit. Now, Docker has the same sort of issue with its flag for binding volumes into a container, where it uses this colon separator, and they actually have a longer form flag. And the way you write the bind mount is you say, I want to -- mount, and the type is bind, and the source is, say, MIDR, and the destination, and I can also call it the target or write it out long form, is, let's say, Vista in the container. And I'm going to run just an Alpine container, and then I'm going to show mount to see that it is mounted at Dester. Then I'm going to look in Dester and see my file, which is in that directory. So doing exactly the same thing as the bind flag, but it's following the same format as the Docker mount flag. And this has the kind of advantage that we can have tools such as things like SnakeMake and Nextflow, which construct Docker mount instructions, also construct the same thing for Singularity now. And if I have a path which contains a colon or some other strange characters which will be interpreted by the shell, I can quote these, and these fields, like they are in Docker, are actually parsed by a CSV parser. So if you imagine that we've got three fields here separated by a comma, we quote them and escape them as we would if they were in a CSV. And then that's how we handle special characters and things in these paths that we're trying to bind. So it's just an approach to kill two birds with one stone, more compatibility on the command line and this quoting type issue. There's several more features and things there, but I'm aware that we're getting towards the halfway point. So what I'd encourage people to do is take a look at our changelog and grab the master branch of the SingularityCE repository and try some of the things out. If you go to the user guide and the admin guide, I posted a link in our Slack to current CI builds of the just updated guides. And you will find that in these things like the GPU support does include the Nvidia container CLI notes. Or the mount flag stuff is in there too. The admin guide, if we look at installing Singularity, We do now list as requirements. We talk about the external binaries that we're using and how we find them, what we do for that. And we have notes about these non-standard environments now. So that's just a quick look at some things, and I'd encourage you to go and take a look if you can. Any questions before I hand over to Adam for the next topic we got to discuss? Okay, Adam, do you want to take it away?
Yeah, thanks, Dave. Well, it looks like a great release. Really excited to see that go out. I've got an issue to raise that started down at the development level, I guess, but has implications for at the user level when installing, particularly if you're using RPMs built from source. At the prompting of Dave, figured I'd raise that here so we can get it in front of everyone and hopefully find a great way forward that's inclusive of everyone's needs. So to dive right into the details, I'll start with saying, Singularity itself is written in Go primarily. Go as a language has a very clear maintenance policy that states bug fixes and security releases are only provided for the last 2 versions of Go. So released twice a year. So the current version 1.17. That would mean that 1.16 is the oldest kind of supported officially by that community. In Singularity, we have a more complicated situation than this currently. We support people building from the EPEL version of the Go toolchain, which the latest available there is actually 1.15. So this is older than the officially supported version, but this is the newest version supported by EPEL. Where this comes into a problem is, since the Go language has such a clear maintenance policy for the language itself, maintainers of some of the Go modules that we use as dependencies are free to take advantage of new features, and they're starting to do so as soon as support is present in those two recent versions. And this ends up breaking our approach where we're trying to build with EPEL, because some of these external dependencies are actually leveraging parts of the language that are not available in Go 1.15. EPEL does backport, as I understand, security fixes in the Go toolchain, but they don't, of course, backport new language features. So this came out very to the forefront recently with the dependency we use to do kind of stuff with the shell kind of in Golang and vdan.cc/sh specifically. Recently dropped support for Go 1.15, and that's used in Singularity 3.8 as well as the upcoming 3.9. That version, the newest version that was released of that dependency, not a security update. So this isn't important for that reason, or at least not yet. But it does, raise the question of how we're going to handle these types of things going forward. We've had a discussion about this. The ticket number, I think, is 345 in the SingularityCE repo. Really, the priorities I think that have come out is we need to have a way to support people who are building from source, building RPMs using RPM build from source, but ideally also have a way where we can stay up to date and track our external dependencies, so we're not having to choose between being able to build and being feature complete or being secure down the road. So I've thrown a couple of just kind of brainstorming ideas in that ticket, just to quickly go over them here. First one, update the instructions in the CI scripts. So the instruction of how to build from an RPM from source, and the CI scripts that do the same thing, to actually leverage the official Go toolchain, one of the most recent 2 versions. So this would clearly make it so that we could build using the latest dependencies. And the second approach is actually to continue using the EPEL supported Go toolchain and updating the dependencies, which would cause an incompatibility and cause the build to fail. But have a patch set that's maintained to kind of bridge that gap. So when you're building with RPM builds, the Singularity source and any external dependencies that need to be patched in order to run with that version of the Go toolchain would have a patch set available. So I think either of these approaches, and there might be more ideas here. I'd love to hear them if there are. The goal really, is to allow us to keep advancing dependencies and leveraging everyone else's, great work in the open source community while still keeping the build and install workflow for current users. So again, the issue number 345 in the SingularityCE repo. Would love to hear if anybody has any thoughts on here, but if you're watching this recording, or if you're just, too shy to speak up, would love to see your contributions and your thoughts in that ticket. So I'll pause there.
First, a question on the patch set. Are you talking about a patch set to Singularity, right? So that it would, right? That's
well,
not a
in this
patch set to Go, right? Patch set to
yeah, in this case, it would actually be a patch set to an external dependency of Singularity, so not the Singularity source itself, but this would be the mvdan cc/sh that would be patched. But yeah, we wouldn't be patching the toolchain, we'd be patching the source that ends up getting built into Singularity.
So you would, oh, so it would get into the tarball that RPM build uses, basically, right? Including, because that's, you'll patch the vendor or whatever, wherever it reads in that part.
Yeah, that would be the idea.
Okay. That will work. Something I ended up doing in another package I build, Vault, is I give it the whole tool chain of Go and a tarball, so that it unpacks that as well. So
All right.
instead of giving one tarball, there's two that the RPM uses.
Oh, that's an interesting idea. Yeah, would you be able to point me to a reference for that in that issue? I'd love to take a look at it.
Yeah, I mean, it depends on the build system, how it's done, but actually, I mean, Apple, what I care about mostly is the Apple build system. And the one I'm talking about isn't on the Apple build system, but the Apple build system has the same ability. You can upload source tarballs, and I'm pretty sure you can have more than one per package. So, but it's true that it will not allow doing any downloads during build time. So as long as, except for your preloaded tarballs, so you won't download anything from the internet. It prevents that. So, so that's one possible way to do it.
Right, great. Yeah, if you wouldn't mind dropping me just a pointer to that somewhere, I'd
put a pointer
definitely take a look at it.
I can put a pointer to the other package that I do that with. But like I said, it's on the Open Science Grid build system that I use, which is also Koji, just like the Apple Fedora system. So they're similar, but they have different ways of uploading tarball. So I think it should work. I'll have to do a test thing, I think.
Great. Yeah, sounds good. Appreciate that.
Thanks, Dave. Yeah, we're looking at this because obviously we see on issues and things, we can see that several people are using package builds with the suffixes on that those RPM builds put on. So cool. Adam's got another item, just a very quick update about what he's been up to with the SIF v2 code base.
Right. Yeah, so I think if I'm correct, last time I kind of phoned in an update, version 2.0 was released of SIF. So just an update on what's happened since then. It's actually an update for version 1, which did two things. So there was an object alignment issue, which has been present since the very first version of SIF. Singularity kind of gets lucky and it doesn't affect the ability to run containers there, but at a SIF level, there was definitely a bug there that's been present for a while. So at the moment, we're maintaining version 2 and version 1. Although with the version 1.7 release, which fixes this object alignment problem, we've also officially deprecated the 1.x module now. So anybody attempting to build with a version 1 SIF will now see a deprecation warning encouraging them to upgrade to version 2. We won't be adding any features, like I mentioned in the last update, to version 1. We will be providing critical bug fixes and security patches until we're sure that there's nobody out there using it. And then on, oh, go ahead, Dave.
Let me clarify that. So you're saying that the SIF file format has changed already in 3.8. So anything that's been built by 3.8 or earlier is going to be deprecated on 3.9. Is that what you're saying?
No, it's not the format itself. So the SIF file format itself hasn't changed. It's fully compatible. Okay. This is at the API level. So yeah, as a user, this is fully transparent. In fact, if you're using SingularityCE, the latest 3.8, you're already using the version 2 API, but it's fully compatible with at the image level.
So then what's deprecated then?
So the version 1 API itself. So as a developer, if you're building with version 1, you'll now see a deprecation warning encouraging to upgrade to the version 2 API. Did that answer your question, Dave?
Yeah, so you changed it in the version 1 API itself. So, and that's what you're saying, right? So what?
Yeah, that.
So what if someone is trying to compile an older version of Singularity, but they'll just use an older version of SIF, so it won't matter.
Yeah, it doesn't really affect that. That will use the version of SIF that was leveraged in the go.mod file at that point. So there's really no impact at all there. This would be if you're developing a new project and you're updating your dependencies and you get to the latest version of version 1, it will now tell you, hey, look, there's a version 2 available. Encourage you to upgrade to that.
Okay.
So it's really at the developer level.
Mm-hmm.
And then version 2, so we're actually on version 2.2 now, and I'll just quickly go through these. These are kind of down in the weeds, but that same object alignment fix was released in a 2.01. 2.1.0 added some new options, again, for advanced uses of SIF, where you want to increase or decrease the amount of descriptors you can have. So if you want to have a very complex issue or complex image, you might need more than the standard, which I think is 48. And then also to make the launch script optional. So SIF used to embed a Singularity specific launch script. Now that launch script lives in the Singularity code base, and in the SIF code base, it's an optional feature that you can opt into. And then for version 2.2, really no changes from the API's point of view, but what we have done, we're spending a lot of time thinking about how to do reproducible builds for things like Singularity and SIF. So for SIF tool, we've actually gone and done the end-to-end to make a fully reproducible build. So this is at the point where if you, Dave, were able to, you checked out the same version, the same commit of SIF tool that I did and built it, we would actually end up with the exact same hash. So it's reproducible in that with the same source at the same commit, you should get the exact same binary out at the end. So true, source to binary reproducibility. So yeah, I think that's about it on the SIF side.
Thanks, Adam. So what I'd like to do now before we move to kind of open questions is basically make a bit of an appeal about getting input on looking forward after 3.9. So we have a public roadmap, and our roadmap has things which have now been crossed off because they're kind of developed for 3.9. These are under heading 3.x features. Now, the 3.9 release in November is definite. But looking forward, we've got some features here which people have suggested, come up with, which are suitable for a 3.x release. And then we have on the roadmap too features which have been suggested by people in Sylabs or others, which are really deeper changes. and kind of would really fit in a new major version release of Singularity. So things like kind of really restructuring some of the fake root engines so that we could support containers where Docker files set a user, which they should run as. Reworking the remote command, it's a little bit confusing at the moment and is kind of overloaded with dealing with sort of Sylabs Cloud or Singularity Enterprise endpoints and OCI endpoints and standalone key servers all in this structure. But we can change that without breaking the current CLI. So that's sort of a 4.0 feature. What we're really looking for at this point, as we go through to getting 3.9 into an RC and then releasing it, is what's going to happen after that. Based on our thoughts of features and what there is that would be suitable in a 3.x, or whether most of the stuff we looking at would be a 4.0, a major version type feature, we'll have to make a decision on whether the next version of Singularity is targeting a 3.10 release or a 4.0 release. So really, this is an appeal to anyone who's here or listening, seeing the video, to come along and drop into this roadmap. Anything you think which is a nice idea for Singularity, really give feedback about what you'd like to see in the next version. Is there a particular workflow that isn't well supported and there's something you think would really help there? We've got this period where we want to kind of collect this so that over the next month, as we get to the 3.9 release, we kind of build up a picture of where we're going for the next version. So if anyone's on the call and wants to kind of pitch in now, please do. Otherwise, we can handle any other business, as it were. Any other questions you have, you'd like to ask us, or comments, please go ahead.
Say one thing I was going to ask from earlier, talking about the new mount option that's similar to existing Docker syntax. The types of mounts, what types were available?
So at the moment, we only support the bind type. Okay, Singularity doesn't have the ability to do, for example, named volumes, anonymous volumes, or tempfs mounts at present. What we're kind of doing with this flag is looking towards that as well. There's actually an issue opened right now on the Singularity repository about named volumes and whether we can implement those. Singularity internally is setting up under certain different flags tempfs mounts. So if you use the contain all flag internally, we're setting up a tempfs for the home directory and /temp and making those available. So something we could definitely do in the future is open that up so it starts supporting more of those types, which Docker does for certain. Okay. But we'd really like to hear about people's use cases and workflows for this. What I mentioned in the issue talking about named volumes is that Singularity is quite often used to run containers in parallel across many hosts. And we don't have an architecture where there's a central service somewhere which can coordinate everything. So what does it mean when you ask for a tempfs mount or a named volume if you're submitting across, say, 100 nodes and an MPI job or something like that? These are the types of things we have to pin down in order to go forward with this, because the kind of architecture of Singularity is a bit different to the way Docker works.
Okay, yeah, because well, I was actually just dealing with this in my case today on a cluster I'm responsible for. We have a new GPFS file system that I was having to bind to a container that my users are launching with a, well, it's part of a, PBS scheduler that they're running these jobs on the scheduler with. And we were just having the discussion today whether or not we just use the bind parameter with our Singularity EC command, or maybe go to the Singularity conf file and do the bind there. So that's kind of the use case I was in today.
Okay, so yeah, for kind of whether or not to default bind a big sort of like project file system in, different sites have different views on that. So I used to work at an HPC site, and we had it set up so that our GPFS and Lustre file systems were always bound in by default. So they were in the singularity.com. But there are other sites which don't like to do that. They want to explicitly bind in all the time. I've also known sites where they have done some Prolog work in a scheduler, or on modules, they've set environment variables. There's a Singularity bind environment variable you can set, and the Singularity mount environment variable, which can also be used to set what is bound in. So sometimes if people have complex kind of situations, they've used that.
Okay.
This mount thing with the type there, a GPFS bind in is always going to be a bind mount. It's not going to be the other type supported by Docker, unless we went the whole hog and looked at kind of named volumes and how you can have different storage providers for named volumes. And, you know, that's how Docker in big deployments, you can point it at some kind of object-based storage or something in the back end.
Okay. Yeah, I guess in my use case, so on our head, what we're calling the head node that hosts our PBS scheduler, we have some, well, various mounts that we're doing. It's an Ubuntu operating system, and we do the mounts locally under the MNT directory, and then we're doing the binds to the Singularity container from there. But yeah, actually, that's our exact use case. So like you were describing, we previously were on Lustre, and we actually just finished doing a data transfer from the old Lustre system to the newer GPFS file system.
Yeah, I mean, this would be a great thing to kind of maybe bring up in the CE Slack channel, see if there's different people with different ideas. And like I said, this issue has come up, and we're really interested in finding out what people are trying to do with these mounts, because we've had requests, but we're really trying to collect information about people's use cases and what they really need for these.
Sure. You had also mentioned the home directory. That's an additional one we are binding as well, because with our environment requirements, I guess the simulation that's taking place, the software simulation, there's some context that's required in our user home directories. So I just wanted to mention that too, since you had mentioned binding user home directories.
Okay, great. Yeah, it'd be good to find out a bit more about the types of things you need. Anything else to raise? Ad, Adrian, Mike, Dave?
Nothing here.
Okay, I think I am going to go out and enjoy the sunshine. It's rather hot in Dallas for October, so I hope everyone else has a good evening also. Thanks for joining us, and please do drop by the Slack channel or the SingularityCE Google Groups mailing list if you have any questions. And note that we've got this Sylabs SingularityCE community repository. That's where the roadmap the meeting notes and things go, and they're editable through HackMD. So if you want to drop anything kind of on the roadmap as a suggestion or whatever, you can do so directly, and we'll see it. Thanks for coming, everyone.
Thanks. Take care.
See you.